Good afternoon everyone, and welcome to today's worked exam answer video, although you're getting two worked exam answers today because I've chosen two periodicity type questions, the first of which is thinking about a range of different properties, and we've got to think about which order for the elements is correct for the associated property going from smallest to biggest. And then I've chosen a question related to second ionisation energy, again focusing across period. Oh no, we're not just solely focusing across period 3, my apologies, because neon's in there as well. But second ionisation energy questions I know can be troublesome for students, so thought that I'd have a look at these two together in one. So 2 for the price of 1 today to start off our week, and I know most of you, if not all of you, will be back at school after half term today, so yeah, there's another reason for me to be generous and give 2 questions today. So starting with the first one, we have to find which elements are shown in increasing order of the stated property. So for example, for atomic radius, do the atoms get bigger going from phosphorus to sulfur to chlorine? For first ionisation energy, do they get bigger going from sodium to magnesium to aluminium? That sort of idea. The other two we've got to decide about are electronegativity and melting point. So as well as being a periodicity question, because for the group 3 elements in particular, we do need to know trend in atomic radius, first ionisation energy and melting point. Electronegativity is a bit more of a general trend that we need to know about in terms of across period and down groups, which comes up in structure and bonding. So there is a lot going on in this question. Now, the first thing that would probably help us out here is if I were to write out the order of the period 3 elements from left to right. So sodium comes first, then magnesium, then aluminium, then silicon, then phosphorus, then sulfur, then chlorine, and finally argon. So they've chosen different combinations of these elements in these different questions. So we've got atomic radius, does it increase from phosphorus to sulfur to chlorine? So those 3 there. So that would mean that atomic radius would need to increase across a period, and that is absolutely not the case. Atomic radius decreases as we go across the period, so therefore these elements would need to be the other way round. Now, in terms of why the atomic radius decreases as we go across the period, I know this isn't what this question is asking, but while we're here, the reason why the atomic radius decreases across the period, because we've got an increase in the nuclear charge, which is the number of protons in the nucleus, and because the shielding is the same or similar, I'm going to use same because I can fit it in there, either would be fine, same or similar, because the shielding is the same, i.e. all of the electrons are going into the same main energy level, there's no change in the distance of the electrons based on the energy levels, if you see what I mean, and therefore there can't be any more shielding, because shielding comes from inner shells shielding the outer electrons on the outer electron shell from the pull of the nucleus. So because we don't change the shielding and we have got more protons, those additional protons can pull the atoms in, tighter, so the atoms are smaller. So atomic radius decreases across a period, not increases. So that one is definitely wrong. Now, second one, and this is probably the hardest one, first ionisation energy. And I say this is the hardest one because we've got to know about the general trend across a period, and the general trend is that it will increase across a period. And we've got sodium, magnesium and aluminium here, so we might be thinking, oh, this is looking quite promising because, yeah, generally it does increase across a period. But there are 2 deviations to this trend, or 2 anomalies, and one of them is as we go from magnesium to aluminium. So everything looks like it could be right, but it's not, because actually aluminium dips and takes less energy to remove an electron from aluminium's outer shell than it does magnesium's, and that's because we jump from the 3s sublevel to the 3p sublevel, and the 3p sublevel is higher in energy. So it's not going to be that one either. General trend would suggest so, but we have the anomaly. So if it was sketched on a graph, and I'm sure lots of you will have seen this, we would see the point for aluminium lower down in terms of position on the y-axis, which would be ionisation energy, or log of the ionisation energy, the first ionisation energy. And that dip from magnesium and to aluminium is because aluminium's electron configuration ends with 3s2 and then aluminium's ends with 3p1, and that's a higher energy sublevel. So it's not that one either. Next up, we've got electronegativity. Now, the way that I remember what's going on with electronegativity is I remember that fluorine is the most electronegative element, and fluorine in relation to period 3 is here, so it's sitting above chlorine. And so fluorine's the most electronegative. We must have an increase in electronegativity as we go across, and if fluorine's the most electronegative, it must decrease in electronegativity as we go down a group. So if we've got sulfur, phosphorus and silicon, and for this question to be correct, we need it to increase from sulfur to phosphorus to silicon, that's not correct, because that shows that we're going to be increasing as we go from right to left across a period. And if that was true, fluorine would not be the most electronegative. So by remembering that fluorine's the most electronegative, I'm saving myself having to remember the trend across a period and the trend down a group. So not electronegativity, so think about F there being the most electronegative. And therefore, by process of elimination, we now know that it's going to have to be D. But obviously we would need to check, or we wouldn't necessarily need to, but it'd be good to check that we agree that D is right. So melting point, we've got argon, chlorine and sulfur. So argon, chlorine, sulfur. Now, melting point is another one where it's potentially a little bit tricky because we don't have a set. It doesn't increase all the way across, it doesn't decrease all the way across, because melting point is all to do with structure and bonding. So structure and bonding wise, we've got 3 metals that will have metallic lattice structures. We've got silicon, which would have a giant covalent structure, and then we've got these 4 here that would all be simple molecular. So there isn't a set, oh yeah, it's going to increase as we go across, and that's because we've got metals and then we've got non-metals. These 3, argon, chlorine, sulfur, are all molecular, and when it comes to the melting point of our molecular substances, we need to be thinking about the size of the molecules. They're all going to have van der Waals intermolecular forces. We've just got to figure out which has the strongest van der Waals forces between the molecules. So argon we know is going to be monatomic because it is a noble gas. Chlorine we would need to know is diatomic, so Cl2. Sulfur, which we probably haven't come across until periodicity, is S8, and phosphorus is P4. Now we don't tend to use these. You probably use phosphorus as P4 in the year 13 version of periodicity. And it's obviously important that we remember it here, because I have seen them ask you about all 4 of these together. Obviously we've only got 3 of them here, but will the melting point increase from argon to chlorine to sulfur? Yes, because argon is just a single atom. With chlorine we've got 2 atoms in our molecule, and with sulfur we've got 8 atoms in our molecule. And the larger the molecules, or the larger the atoms, more atoms to make those larger molecules, we've got an increase in MR, we've got an increase in the number of electrons, and therefore we've got stronger van der Waals forces. So they are all molecular, but sulfur, solid, chlorine, gas, argon, gas. Makes sense. So I would agree that that is the case. Stronger van der Waals, therefore increase in the melting point. So thankfully D is correct, but hopefully it's been helpful to work through why D is correct and obviously why all the others are wrong. And that was my first multiple choice question for today. Second one, as I've already alluded to a little bit, is highest second ionisation energy. So when we're thinking about second ionisation energy, we want to be considering going from our singly positive ion rather, and taking off a second electron to give us a 2+ ion, both of which would be in the gas phase, and then the electron that we've taken. So we've got to think about which second electron would take the most energy to remove. So would it be going from Na plus to Na 2+, or magnesium from plus to 2+, neon from plus to 2+, or argon from plus to 2+. I don't need to write all of them out again, hopefully you get the idea. Now, in terms of how to approach ionisation energy questions, I'd be tempted to write out configurations, or certainly at least look at what groups of the periodic table these elements are in. So we have got sodium in group 1, magnesium in group 2, and then both neon and argon are in group 0. They're both noble gases. So how does that help me? Well, once we've removed the first electron from atoms of these 4 elements, argon and neon will then have 7 electrons in their outer shell. Magnesium will then have 1 electron in its outer shell. Sodium will lose that shell completely and will drop into the next closest to the nucleus shell, and then it would have 8 in that shell. That might have given some of you the clue that you needed. It might not have done. If we were thinking about first ionisation energy, we'd be thinking one of the noble gases, and we'd be thinking about the smaller of the 2 noble gases, so we'd be thinking neon, because these both have a full shell, they want to have a full shell, they're not therefore going to very easily give it up, and also atomic radius decreases across a period, so the electrons in the noble gases are held most tightly by those nuclei compared to its counterparts across the period. So first ionisation would be neon, but we're thinking about the second. Now the second, we always want to be looking to see if we've got an element in group 1. Why? Because when we remove that second electron, we are taking it from the shell closer to the nucleus. So the sodium ion is 2,8, whereas the atom before it was 2,8,1. So we took the only electron that was in the 3rd main energy level first. Then we end up taking an electron from the 2nd main energy level, and that main energy level is closer to the nucleus, and if it's closer to the nucleus, the protons are going to be holding it more tightly, and therefore it's going to be harder for us to take it away. So you always, in these sorts of questions for highest second ionisation energy, want to be looking for a group 1 element, and in every question that I can recall off the top of my head, there has been a group 1 metal as one of the options, because of removing the electron from a shell closer to the nucleus. Okay. And some of you might be thinking, well, why is it not neon? Because if neon only has 10 electrons initially, so is 2,8 as an atom, so then it becomes 2,7 in its first ionisation energy process, and then it would turn into 2,6. So why is it not neon? Because we're still removing 2 electrons from that 2nd main energy level. And I agree. the jump with sodium from first to second would be the largest, but obviously that doesn't quite answer the question if we're comparing sodium with neon. Sodium, having got that extra proton, it's got 11 protons, whereas neon only has 10. So the electrons will be held slightly more tightly in sodium than they would be in neon, and that's why the sodium pips neon to the right answer here. Hopefully that's made those a little bit clearer, but as always guys, any questions, please do not hesitate to ask. I hope you all have a great first week back at school or college, and if anyone's got any questions for me, hit me up in the comments. Thanks for watching guys.